Okay, welcome fourth graders to another science video lesson. Hopefully you guys once again have your notebooks in front of you, even your science textbook if you would like. So you're looking at the notes while you're paying attention here, and you should be ready to go for the test. So today we're going to be talking about using electrical energy. Now there's different ways that we use electrical energy. Okay, we use electrical energy like in blow dryers. We use electrical energy to produce heat. And we use electrical energy to heat our homes. We use electrical energy to light our houses using light bulbs. One of the key things that you need to know to understand how heat works or how things get hot is called resistance. Okay? What basically happens is electrical energy is traveling along a wire. Okay, as you know, metal are good conductors of electricity. So the electricity is running down the wire, and let's say it comes to a light bulb, into a light bulb, or at the end of a blow dryer, or the metal things that are underneath, that are on your stove that cook your food. It's called resistance. What basically happens, and we talked about this in class, it's like if I was pushing up against a wall, right? Let's say the wall was trying to move me, and I was holding the wall back from pushing me, okay? Eventually my arms would start heating up. They would get tired. They would start to burn, okay? The same thing is going on here. You have electrical energy that is flowing, okay, this way. And the resistors, okay, hold back the electrical energy. And when the resistors hold back the electrical energy, they get hot. Okay? Same thing with like if I was pushing against a wall, my muscles would start to heat up. The same thing, you have resistors in a blow dryer. You have resistors on your stove. You have resistors in your house. You have resistors at the inside of a light bulb. Those are called filaments, and they hold back the electrical energy. The higher you turn up the electrical energy, the more the arms are going to burn. The more the resistors are going to burn. The hotter the resistors are going to get. Okay, so once again, if you turn up the heat, the resistors are going to, you turn up the electrical energy, the resistors are going to have to hold back harder, and the more heat is going to be produced. Okay, so resistors are really key for understanding how electrical energy is converted into heat. Another thing, electrical energy is also can be converted into motion, like fans that are used to cool our house. Alright, let's talk about how electrical energy gets to our houses. Electrical energy first starts off in a power plant. Okay, you can see the power plant here. Now, power plants, the energy leaves the power plant at about 25,000 volts. Now, 25,000 volts is not enough electrical power for it to travel along these lines and get to your house. So these transformers, okay, a step-up transformer is used to boost up the power to 400,000 watts. Then it is able to travel along the wires. Now when it gets down to your house, 400,000 volts is too strong to be used by your house. A lot of the appliances in your house only use about 240 volts. So what happens is you have another transformer at your house that step down. It's called a step-down transformer that brings down the voltage from 400,000 volts to something really low, like 1,000 volts, that gets spread out to all of your house and goes to some of your appliances that once again only use between 100 and 300 volts. So once again, it leaves the power plant, it gets a step-up transformer right before your house. It goes through a step-down transformer, okay? Then it is used by your house. Now, Sometimes the if you have too many things plugged into your house, like are into your sockets, you have a TV going, a stereo going, your refrigerator's going, your friends are over and they're cranking up the stereo. So you have all this voltage going to your house. Sometimes it can be too much for the house, okay? Now that can be bad. So a fire can start because the resistors will get too hot because you're asking all this energy to come to your house, and your house is like, whoa, 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 and a fire could start because the resistors get too hot. The wiring starts to get hot and burn, and it can cause a fire. So what happens is you have these circuit breakers. As soon as the voltage gets too high, if you ask too much electrical energy to come through your circuits, this circuit breaker will shut everything off and create an open circuit, and that will prevent any fires. Also, you have surge protectors. Surge protectors do much the same thing. If you have too much electrical energy that you're asking to come out of these sockets, the surge protector will shut everything down before it damages it. Okay? Fuses are inside of these circuit breakers, but what basically happens is when it gets too hot, there's a thin piece of metal in the fuse, okay, and it breaks, creating an open circuit because now electrical energy can't travel along the fuse anymore. Right? Some facts that you need to focus on. Electrical devices change the electrical energy into other kinds of energy, such as heat energy, light energy, and motion. Okay, so keep that in mind. I believe that is about it. We talked about resistance, all the different ways we use electrical energy. We talked about surge protectors, step-up transformers, step-down transformers, power plants, circuit breakers, fuses. I think that's about it. I hope you've enjoyed this lesson on using electrical energy. Look forward to seeing you guys in class, and I'll talk to you tomorrow.